Assalamu alaikum wa rahmatullahi wa barakatuh. Hi there and welcome to another video from Tabarak Private School. In this video we are going to talk about how to do implicit differentiation with Mr. Yasser Ahmed. For implicit differentiation, in the first, what are explicit and implicit function? What are explicit and implicit function? So in general, the explicit function, it's a function in which the dependent variable has been given explicitly in terms of the independent variable. So that means, in general, y in terms of x, or y is in terms of x. For example, y equal x squared, y equal 3x plus 2, y equal root of x plus 1 over x. All of this is called explicit function. Why? Because y is in terms of x. Okay, what about implicit function? When an equation contains two variables, but neither of them is given explicitly in terms of the other. For example, x squared plus xy plus y squared is equal to 25, okay? So look here, we have the concept of each of which, the explicit function and implicit function, but it's very easy if you say that the explicit function, y in terms of x, or y in terms of t, or y is a subject in another variable, all right? But what about implicit function? When an equation contains two variables, but neither of them is given explicitly in terms of the other. That means I have x and y together, and they cannot make one of them as a subject. Okay. For examples here, for explicit function, here I have y is equal 3x minus 2. Y is equal 3x minus 2. So y in terms of x, y in terms of x. Also in the second one here, y is equal x squared plus 5. So also y in terms of x. Okay, show us, teacher, examples for implicit function. I have here, in this one first, I have x squared, or sorry, y squared plus 2yx minus 4x squared, it's equal to 0. Or y to the power 5 minus 3y squared times x squared plus 2, it's equal to 0. In both equation here, I have mix between x and y, and so hard to make one of them as a subject. So this is called implicit function, and here it's called explicit function. Let's show us, I'm going to show you here, this is implicit form, x times y is equal 1. And you can change this equation to be in the explicit form. How? By dividing by x. So y is equal 1 over x, or x to the power minus 1. So the derivative here is what? To differentiate this explicit form, we just need to multiply this power minus 1 by coefficient. Minus 1 times 1, it will be minus 1. The reduced power by 1, minus 1, it will be minus 2. So after that, to write the answer in simplest form, the power here take negative sign, so it goes down to be in denominator. So the final answer, it will be minus 1 over x squared. So in general, you have to know that explicit is y in terms of x, and the implicit means y and x together. Y and x together. That is the difference between explicit and implicit. Okay. In differentiating, we wanted to be able to use either. Okay, I want to tell you something first here. After working through this chapter, you should be able to know the difference between explicit and implicit functions. Number 2, differentiate functions given implicitly. Number 3, find the equations of the tangent and normal to curves given implicitly. So let's go to start, or to know how to differentiate these functions. Here, differentiating with respect to x, the derivative here is called d respect to dx, or d over dx, or d by dx, deriving when denominator agrees. What's the meaning of that, mister? For this example I have here. d respect to dx for x squared. So I have to compare this variable and denominator. I want to differentiate respect to what? Respect to x. And here, the function contains x. So denominator agrees properties. So I can differentiate here normally. 2 times 4 is 8 and reduce power by 1. Go to the second one here. d by dx for 3y squared. Oh, attention here. The unknown here is what? Is x. And the unknown here, or the variable here is y. And here is x. So denominator disagrees. So you have to use a chain rule. Okay, we have some, or I have some steps to solve any implicit function or process for implicit differentiation. You have to follow these steps every time to find the implicit differentiation. Number one, differentiate dy over dx. We need to differentiate both sides with respect to x. Y is assumed to be a function of Lx. So I want to find d respect to dx for both sides. Second step, collect like terms. All dy over dx in the same side and everything else on another side. So I have 2 steps till now. The third one, factor out the dy over dx and solve for dy respect to dx. Okay, I have here example. Find dy respect to dx if 3xy plus 4y squared is equal 10. So what we have to do to find the differentiation of this expression? What we have to do here? Look, 3xy plus 4y squared, it's equal 10. This term contains x and y together, so this is called implicit function. To find the derivative, we just need to differentiate both sides respect to dx. So I will differentiate all this side and the other side, which is 10. Which is what? 10. So the derivative of 3xy plus 4y squared. In the first term here, I have product rule. So use product rule for 3x times y. So the derivative of y is dy over dx. I think no one can understand this. You need to use the board to find the answer of like this question. Let's go to solve some question on the board. Hi all, we back to our lesson. What are explicit and implicit function? Explicit function means y in terms of x. So y is in terms of x, or y is given explicitly in x. So look here, y is a subject, y is a subject, y is a subject. And it's in terms of x. It's in terms of x. It's in terms of x. Or y is a function in t, so y is given explicitly in t, like y is equal 5t cubed minus 2t plus 1. So explicit function means I have subject and only one unknown. Y in terms of x or y in terms of t. What about implicit? Implicit when an equation contains 2 variables, but neither of them is given explicitly in terms of the other. For example here, x squared plus xy plus y squared is equal to 25. This implicit function, it contains x and y together, and we cannot make anyone as a subject. Go to the next one also, x squared plus y squared is equal to 25, but this equation I can transform this one to be y is a subject by move x squared to other side. It will be y squared is equal to 25 minus x squared, and y here to remove this squared, we just take square root for both sides. Now our question, how to differentiate implicit function? How to differentiate implicit function. Now we will go to solve some question from textbook. Open your textbook on page 208, exercise 10a. In exercise 10a, page 208, differentiate with respect to x. We will choose some letters like letter A. We want to differentiate with respect to the x for y squared. Letter D, d respect to the x for x times y. So to differentiate this, you have to use a chain rule. Why? Because the variable here is x, and the variable here is y. So it's disagree. This is x, and this is y. So just need to find dy over dx. How to do that? We differentiate this normally to y times dy respect to the x. Y, we make it like that. Y, we do it dy times dy over dx. You know why? Because we want to divide this. It's d respect to the x for y squared times dy respect to the x. So you have to pay attention to that. D respect to the y for y squared times dy over the x. Here, the variable here is x, and the variable here is y, so the variable disagree. So I can use a chain rule by dividing this. I will divide y respect to dy, then multiply all of that by dy over dx. Attention to that. Dy divided by dy is cancelled, so you will get d respect to the x. Now it is equal to the derivative of y squared respect to y, it will be 2y. And this multiplied by dy respect to the x. Go to the next example. In the next example, here I have d respect to the x for x times y. X times y. This represents product. Product rule. So because I have multiplication of two different functions. First one is x and here is y. So we need to separate this to be u and v. So I can divide this to be u is equal x and the v is equal y. Now differentiate each of which respect to the x. U dash, I will differentiate respect to the x, and the unknown here, or the variable here is x, so it's agree. So the derivative of x, it will be 1. To differentiate v, the derivative of y, it will be 1 times dy respect to the x, because I differentiate y respect to the x, so the variable disagree. Now using product rule, you can do that. U times v dash, so x times 1, it will be x times dy respect to the x, plus v times u dash, it will be 1 times y, it's equal y, and this is the final answer. Let's go to take another example. Have to attention to that. For these kinds of problems, anytime you differentiate a y value, add dy respect to the x for this function. Okay, go to the question 2. Find dy over dx for each of these implicit function. I choose here 2 letters from question 2. And the letter C, x squared plus 3xy equal 2y squared plus 4. As you know, to differentiate or to find the derivative of implicit function, we just need to differentiate both sides respect to the x. So the first step here, differentiate both sides with respect to x. That means I wanted to find d respect to dx for all terms. So we just need to make that d respect to dx for the first term, which is x squared, plus d respect to dx for the second term, which is 3x xy, it is equal d respect to dx for 2y squared plus d respect to dx for 4. So, back again for this from the beginning, I have implicit function x squared plus 3xy plus equal 2y squared plus 4, and the question here find dy over dx for each of these implicit function. You know that to find the derivative for any implicit function, first step every time, we just need to differentiate both sides or all terms with respect to x, or we need to find d over dx for all terms. D respect to the x for first term, which is x squared, plus d respect to the x for the second term, which is 3x times y, and d respect to the x for this term and the second side, 2y squared, plus d respect to the x for 4. Now we're going to differentiate each one. Now look at the variable here. The variable here is x, and the variable here is x. So the variable is agree. So I can differentiate this normally, as you know, using power rule. The derivative of x squared, it will be 2x plus. We're going to the second term. I want to find the derivative for 3xy. Oh, mister, we just need to divide this to be a product rule. Yeah, it's a product rule. I have here u, which is 3x, and v, which is y. So we can make that. U is equal 3x, and v, it's equal y. Now differentiate each of which respect to the x. The derivative of 3x, it's equal 3. And the derivative of y, it's equal to 1. It's correct. Not correct. It's 1 times dy respect to dx. Why? Because I differentiate y respect to dx. So the unknown disagree. Now to find the derivative of this term, you can make that u times v dash. So it will be 3x times 1, it's 3x times dy respect to dx, plus v times u dash, it will be 3y. It is equal to now we're going to the second side. I want to differentiate the first term, d respect to dx for 2y squared. Okay, look at the variable. The variable here is x, and the variable here is y. So the variable disagree, so I can do that. 2 times 2, it's 4y, reduce power by 1, it will be 1. All of this times dy respect to the xy, because this is implicit function, or I differentiate y respect to the x. Plus, now the derivative of 4, you know that the derivative of any number, it's equal to 0. So back to this again. That is the derivative of the first term. All of this represent the derivative of the second term, and this represents the derivative of the first term and the other side, and the derivative of any number, it's equal to 0. So we need now to find dy over dx. What is the second step to find dy over dx? What we have to do to find dy over dx. And first, I want to keep all terms which contain dy over dx in aside. How many terms contain dy over dx? I have here this term, and I have this term. So I want to keep these terms in aside, and another term is in the another side. So I have here 2x plus 3y. Just shifting that to other side, it will be 4y. Times dy over dx. After shifting this, it will be minus 3x times dy respect to the x. Now, we want to find dy over dx. So the last step, we want to factor out dy over dx, or take dy over dx as common factor. So from here, you can take dy over dx as a factor from these two terms. So the remaining here will be 4y minus 3x. It's equal, and I have here 2x plus 3y. So finally, to find dy over dx, what we have to do? Finally, to find dy respect to dx. I need to find this, dy over dx. So we just need to divide by 4y minus 3x. So it's equal 2x plus 3y divided by 4y minus 3x. That is. So, every time you have to pay attention to that. To differentiate the implicit functions. If you differentiate x respect to the x, we have normal differentiation. If you differentiate y respect to x, differentiate it normally, then multiply the derivative by dy over dx. Let's go, or let's try another example. Letter G in question 2. The question here, find dy over dx for each of these implicit function. I have 1 over x plus 1 over y. It's equal to. It's a very easy question, but you have to attention here. I have this form, fractional form, 1 over x and 1 over y. I told you before, to remove any fraction, what you have to do? We just need to multiply all terms by the product of the denominators in these fractions. So we need to multiply all terms by x, y. So multiply her by x times y, and her by x times y, and her by x times y. So attention to that. X divided by x, it's cancelled. So I have 1 times y, it's equal y. Plus y divided by y is cancelled. So 1 times x, it will be x. All of this is equal to xy. Now to find dy over dx, we just need to differentiate both sides respect to the x. So we need to find d respect to dx for all terms, for y, and d respect to dx for x, and d respect to dx for 2xy. So to find dy over dx, we need to differentiate both sides respect to the x. Now go to find the derivative of first term. The unknown here is what? Is x. The unknown here is y. So this agree variable. So I can differentiate y. The derivative of y, it will be 1 times dy respect to dx, because it's not like variables. If this x and this x, so you can do that. The derivative of x respect to the x, it's equal only 1. But the derivative of y respect to the x, it's 1 times dy over dx. Plus, here the derivative of x respect to the x, the unknown here is x, and the unknown here is x. So the variable here is x, and the variable here is x, so I have agree variable. So the derivative of x, it's equal 1. It's equal to. Now here, d respect to the x for 2x times y, this is product rule. So I can divide this to be like that, u and v. In u, I have 2x. In v, I have y. Differentiate each of which respect to the x. The derivative of 2x here is equal 2. And the derivative of y, it's 1 times dy respect to the x. Using product rule here, u times v dash, it will be 2x times dy respect to the x. Plus v times u dash, it will be 2y. Now, we wanted to find dy over dx. So, you have only one way here. How? We want to keep all terms which contain dy over dx in a side and another term is in another side. So we need to move this to other side. So 1 time dy over dx, it will be dy over dx. Move this, it's positive, it will be negative, minus 2x times dy respect to dx. It's equal this 2y, and we move this to be with y. So I have dy over dx minus 2x times dy over dx, it's equal to y minus 1. Now factor out dy over dx, or take dy over dx as common factor, so it will be, when we take dy over dx common factor from here, I have 1 minus, when you take dy over dx, the remaining it will be 2x. All of that is equal to y minus 1. So finally, I can find dy over dx by divide this expression by the coefficient of dy over dx, which is 2y minus 1 divided by 1 minus 2x. And this is the final answer. Let's go to take another example. Question number 3, page 208. In question 3, for each of these implicit functions, find dy over dx in terms of x and y. Letter A. For e to the power x times y minus 3 x e to the power y, all of this is equal 10. It's a tricky question. You have to attention here, and you have to revise everything you studied before. Now, I want to find dy over dx. The type of this equation or of this function is implicit because it contains x and y together. So to find dy over dx, we just need to differentiate both sides respect to the x. So I will differentiate both sides respect to the x. D respect to the x for first term for e to the power x times y, minus d respect to the x for the second term, which is 3x e to the power y. It's equal d respect to the x for 10. So I will differentiate all terms respect to x. Now, notice that in the first term here, I have product rule. And in the second term also, I have product rule. It's multiplication of two different functions. First function in terms of x, and second in terms of y. Also here, it's multiplication of two different functions. First function in terms of x, and second in terms of y. And this is the derivative of constant. All of you know that the derivative of any number is equal to 0. Okay. We need to divide this using product rule, so we can divide or separate this function to be u and v. So name u, it's equal for e to the power x, and name v, which is y. To find u dash, the derivative of u respect to the x, it's equal the same function times derivative of the power, it's 1, not effect. The derivative of y, it's 1. No, it's 1 times dy over dx, which is dy over dx. Now, to find the derivative of the first term here, it will be u times v dash. So I have here 4 e to the power x times dy respect to dx, plus v times u dash, which is 4 e to the power x times y. So all of this represents the derivative of first term, minus or plus. This for first term. Now we're going to differentiate the second term. So, attention to that. I have here minus sign. So I can divide this function to be u is equal minus 3x. Don't forget the sign, please. Minus 3x. And v is equal e to the power y. So the derivative of u respect to the x, it's equal minus 3 because it's in terms of x. The derivative of e to the power y, it's the same function, times derivative of the power, derivative of y, it will be dy respect to the x. Again, here in the second term I have minus in the middle. So we just need to divide this function to be u and v, where u is minus 3x, and the v is e to the power y. Now differentiate each of which respect to the x. The derivative of minus 3x, it's minus 3. The derivative of e to the power y, it's the same function times derivative of the power. So the derivative of y respect to the x, it's equal dy respect to the x. Now just do that. U times v dash minus 3x times e to the power y. So it will be minus 3x e to the power y times dy respect to the x. Plus v times u dash minus 3 times e to the power y. All of this is equal to the derivative of any number, it's equal to 0. Now we need to factor out dy over dx, or sorry, we just need to keep terms which contain dy over dx in a side and another term is in other side. So I have this contain dy over dx and this term contain dy over dx. So for e to the power x times dy respect to dx minus 3x times e to the power y times dy respect to the x. All of this is equal. This not contain dy over dx, it's going to other side. It will be positive 3e to the power y. And also this term not contain. Now we want to take out dy over dx, or factor out dy over dx by take dy over dx as common factor. So the remaining here it will be 4e to the power x minus 3x e to the power y. All of this is equal 3e to the power y minus 4e to the power x times y. Finally, to find dy respect to dx, we only divide by its coefficient. So we just divide by this expression. It will be 3e to the power y minus 4e to the power x times y. All of this divided by 4e to the power x minus 3x e to the power y, and this is the final answer. We're going now to another example, letter D in question 3. Also we wanted to find dy over dx. Okay, now we will differentiate both sides respect to dx. 3x times ln y equal d respect to dx for 2y squared plus d respect to dx for 8. Here I have product rule. So using product rule, we divide this to be u equal 3x and v is equal ln y. So u dash, it's equal, derivative of 3x, it's equal 3. V dash, we will differentiate ln y respect to dy. So you have to attention to that. V dash, derivative of ln y means 1 over y. And the up derivative of y, it will be 1 times dy respect to dx. You know why? According to this, for these kinds of problems, anytime you differentiate a y value respect to dx, differentiate it normally, then add dy over dx. So the derivative of this term, it will be u times v dash, 3x times 1, it's 3x, divided by y, all of this divided by dy over dx, plus v times u dash, it will be 3 times ln y. All of this is equal. With respect to dx for 2y squared, the variable here is x, and the variable here is y. Disagree, so differentiate normally. 2 times 2, it will be 4y times dy respect to dx, plus the derivative of any number, it's equal to 0. Now, we want to keep all terms which contain dy over dx and aside. So move this to either side. So I have 3x over y times dy respect to dx minus 4y times dy respect to dx. It's equal, and keep another term is in aside. This term not contain dy over dx, it goes to other side to be minus 3 ln y. Now attention to that. I have y in denominator here, so it's easy for us to remove it by multiplying all terms by y. So you will get 3x times dy over dx minus, we just need to multiply all terms by y. So y divided by y is cancelled. I have here 3x times dy over dx minus 4y times y, it will be 4y squared. All of this times dy over dx. It's equal, minus 3 times y, it's minus 3y times ln y. Now take out or factor out dy over dx by taking out as common factor. So the remaining here, it's 3x minus 4y squared. All of this is equal minus 3y times ln y. So finally, we can find dy over dx by divide the other side by coefficient of dy over dx, which is 3x minus 4y squared divided by, I'm sorry. So this is it's minus 3y times ln y divided by this expression 3x minus 4y squared, and this is the final answer. Thank you, all of you. Goodbye.